Hello, everybody. Welcome to our webinar on Spring Boot 3 and beyond. I have with me Oliver Trollbaum, software engineer at VMware Tanzu and Spring expert, who will give you an update about the newest features in Spring. Thank you. Over to you, Ollie.
Yeah, welcome everyone from my side. I'm about to share my screen here. That should work. I see that there's stuff visible. So let's dive in. So what I want to talk to you about today is the Spring Boot 3 generation and how it lays the foundation for like the future development of Java applications in the Spring ecosystem or Spring applications in the Java ecosystem. As Ulrike said, my name is Oliver Drotbom. I'm based in Germany. I've been working for the Spring engineering team for over a decade, primarily driving the Spring Data projects, but have recently moved on to, let's say, more architecture-related engineering efforts, which I'm going to pitch to you in the very end of the session as well. Yeah, I'm working on developing Spring parts of the Spring framework, basically, of the ecosystem, and I'm also in touch with customers on like what they're trying to build and doing a lot of like requirements engineering, if you want to say so, for the wider ecosystem. Before we start deep dive into 3.0, 3.1, 3.2, and all the things that have been released and that we are currently working on, I want to give you a quick update and summary on like the structure of the overall ecosystem, right? So we have Spring Framework at like not the very bottom. That's probably surprising to many, but it's of course the foundation to all the actual Spring ecosystem projects. What's interesting is that Spring Framework, of course, integrates with a lot of like infrastructure components, such as Reactor or Micrometer, and these infrastructure updates are going to play an important role when we talk about the step to 3.0. That said, like for over a decade now, again, Spring Framework is not the primary approaching point for Java developers anymore. It's Spring Boot, which resides on top of all the ecosystem projects that you can find, and there's also some downstream projects like Spring Cloud that ships with solutions to problems that you face when you're building distributed systems, microservices, etc. The reason I lay this out here is that you can imagine that if we have to change something fundamental, and releasing a major version is a very fundamental release, then it means that all these bits and pieces need to work together and be kind of related to each other when upgrading. So it's not that Spring Framework could introduce a breaking change. We're going to get to one in a minute. And the other projects not working around. So it's been a tremendous effort for us to actually move or incorporate all these infrastructure updates into the framework release and the overall ecosystem. Timing wise, we're looking at the 3.0 has been established for a year now. We actually have the 3.1 milestone, or we had the 3.1 milestone not milestone, but minor version in May. There's 3.2 coming in November, so in a month roundabout. Releases for Spring Boot, release candidates for Spring Boot actually due today. Yeah, there's a bit of stuff in 3.2 as well, which I'm going to give you an outlook on later on. But this is kind of the time frame. So you see that we kind of follow a 6-month cadence basically for like the releases. We're getting into support timelines and whatnot at the very end as well. So what's in Boot 3? The primary thing, and that's actually a thing that keeps a lot of people from upgrading, unfortunately, is that we have lifted the baselines for the JakartaEE APIs from previously 8.7 and 8 to 9/10 for all the web stuff actually requires JakartaEE 10 even. because Tomcat, the web server included in Spring Boot 3, has its recent version on JakartaEE 10 already. The reason this is such an effort is that due to the change from JakartaEE from Oracle to the Eclipse Foundation, they had to rename the packages of all the code in there, which means that you can't really like let a single code base work against both of these namespaces. So we basically had to touch all of our code that was referring to the JakartaEE previously JavaEE APIs and move them to the Jakarta one. So it's been like the wider ecosystem has been affected. And if you want to move your application from a Spring Boot 2.7 to 3.0, then you would have to do this as well. There's a catch here. I mean, you could superficially think it's okay, search and replace. Not all JavaX packages, of course, are subject to that move. But most of them. So to ease the pain, I mean, we've done this already. We've been done over a year ago, actually. But you have to, if you want to upgrade your applications, you will have to make that move as well, as I mentioned. And there's a tool that we provide you that can help with that. It's called Spring Boot Migrator. It's you can just download the release, the jar, run this jar, and it basically gives you it's a thin layer on top of a tool called Open Rewrite, which allows you to perform manipulations on source code, like refactorings, upgrades, what have you. And we're adding a bit of boot specifics on top of that in Spring Boot Migrator. And you can basically run this as it says there, start Spring Boot Migrator. It's a jar that opens up a command line, and you can basically try the migration on your application. So it's twofold actually. It can give you a report on like what would need to be done for the upgrade, and it can actually perform them. So it can basically do the migration to JakartaEE 9 step and change the code and create an individual commit for that, and it will also perform other upgrade tasks that are needed. Rename deprecated properties or all that kind of stuff. So the migrator team has really been busy on covering all the things that have changed in the upgrade and provide these migrations for it, and you can selectively run them and see what it does. So create a branch of your project, run this thing, and then see how far you get with that. It's kind of the best thing we can do. Right, so we're going to come back to this topic later on, but that's basically the fundamental infrastructure step here, right? There's a couple of like developer-facing new features in there as well, right? Usually the infrastructure stuff is important to get your application up and running and to keep it modern. Also something I'm going to leave a word on later on. But for developers, it's usually interesting, like what kind of new features can I use to build an application? The JakartaEE upgrade doesn't really change a thing here. One thing we've put in there is a Spring Cloud Feign successor alternative, when you want to phrase it. Feign has been or part of the Spring Cloud projects for a while. It's been also a predecessor of a Netflix maintained component, and we found it generally useful so that there was no real tie to Spring Cloud in the first place. So Spring Framework now ships with an interface-based web client. So you just declare an interface similarly to the way you work with controller methods and or Spring Data repositories. It's kind of the birth child of these two design approaches, right? You map requests via annotations, and the Spring Data kind of inspiration here comes from the fact that you don't have to write an implementation, but we can derive all that's needed from the method declaration. You can create instances of the web client and then automatically and just call the method to execute, in this case, get request that expands the URI with the given string parameter. So kind of interesting stuff here. What's also in there is the support for HTTP problem details for HTTP. That's an RFC, so a specification on how you would describe errors that occur during like the processing in your application. There's a bit of guidance and a rudimentary implementation that we had in Spring Hatios, because that was kind of the kind of incubator place for everything that's advanced web or advanced REST stuff. We thought it would be generally useful and better placed in Spring MVC in the first place. So this is basically the RFC document. It describes a certain structure, how these responses are supposed to look like, what information they're supposed to contain. And we now have an API for which you, in an exception handler, you can just create a problem detail instance, equip that with the information, and it will result in the format that's specified in there, right? So you can have, like, if you have a client library that understands that particular format, then you can basically produce error information that that library will support out of the box, right? What we've also done, and that's why I actually mentioned Spring or the ecosystem in the first place, there's a project called Micrometer that allows you to instrument code so that it produces information about its runtime behavior. So it can actually measure time. It can count how often a method was invoked and how often an event was published. It can track which SQL statements were executed on a database, and there's actually an API to capture that data, and then there's pluggable strategies. What you want to do with that data? Do you want to send it to a Zipkin or to any kind of other observability software that you might have running in your application? And the portfolio projects were instrumented with that code. So that's an ongoing effort. But like, let's say all the if you're using the REST client or the REST template, it will automatically gather these metrics if you have these one of the publication strategies in your class path, and it will produce that data, so that your application ultimately becomes more observable in your specific runtime environments, whatever tools you use there. Of course, with pretty extensive support in any of the Tanzu runtime platforms for that data. With that, I want to move on to something that's probably, or it's been the biggest feature actually of Spring Framework 6, Spring Boot 3. And native is not a typo in this case here, or mix up on words. Because the initiative, and I'm going to explain what native means here, has been started as a separate R&D project before Spring Boot 3, of course. So there was so what is it in the first place? Let me not get ahead of myself, right? So what is Spring Native? So in the Java world, when you run a Java program, you have a couple of different options to do that. The most prominent way to run your application is using a JVM. So you install a Java runtime on your machine or via your Docker environment in your Docker container, and then you do java-jar, and you actually run the application in that Java virtual machine, right? And it then performs at runtime. There's a so-called JIT, just-in-time compiler, that will monitor your code base for execution paths and then optimize the bytecode even for the actual execution. But what that means is that a lot of, or traditionally, frameworks have worked in a way that on startup, they perform a lot of like preparing operations, and that often, or that contributed to the startup time, and was then kind of countered by the ability to optimize stuff at runtime so that there was a bit of a certain trade-off, basically, just by running these applications. An approach that tries to improve on the startup time is a so-called AOT, ahead of time compilation, which tries to shift a lot of the work that's been traditionally done at startup time to the build time. And we've had significant efforts in both like pre-boot 3.0 as a separate project, but now fully baked into the framework, an AOT engine that like half bootstraps your application or the application context of your Spring application. It assumes a closed world model, so it assumes that your configuration, your profile settings are kind of closed and locked down at this point. And it then replaces or writes actual source code, sorry about that, to avoid reflection at startup. So for every like add component that you have in your application that Spring would usually instantiate via reflection at runtime, we create the Java config code that would just do new your component, what have you, and then resolve all the dependencies and basically have that written down. It's kind of a translator from the annotation-based programming model into a Java config-based programming model, so that you don't have to do that. And it allows us to avoid reflection at startup completely. Most people overestimate the effects of that, because often the amount of time spent at startup is not the container, but like third-party software that's performing some work. But that's kind of an initial interesting step here. And the next and the ultimate kind of goal for this entire exercise is a so-called native image on it, based on a technology called GraalVM. That's an alternative JVM implementation that allows the JVM, or works as a JVM, but has this native images extension that would, instead of like creating bytecode and a jar file and to be run by a JVM, it will actually compile code down into a native binary, performing all kinds of tree shaking, optimizations. It's throwing code away, basically, even from the JDK. That would then allow that native image to really start significantly faster, and a lot of people miss that, run the applications with a lot less memory requirements, right? So quite smaller memory footprint. That's kind of the thing I want to get to. All right, so just from timing, in the 2.7 generation, Spring Boot applications were built and run as JVM applications, and there was a project called Spring Native that explored these other options that I've just explained on the right, the ahead of time compilation and the native images build. In 3.0, this is all folded into the ecosystem projects natively. That includes a lot of configuration and metadata management. One thing that's important to understand for the native images is that due to the tree shaking, what GraalVM does or the compiler does, is a kind of a path analysis through the code. And if a lot of Java projects work with reflection at runtime, like Jackson, Hibernate, what have you, and it's not necessarily obvious from the code paths that certain parts of your code base need to be subject to reflection. And native images kind of turn the how you work with reflection upside down. So while on JVM reflection is available by default, with native images you have to explicitly register resources, classes that you want to reflect on, methods that you want to invoke. And there is a lot of, like, for third-party libraries, there is a so-called metadata repository that includes the necessary information, like for Hibernate, like for each version, it kind of there's configuration files in there that become part of the native image compilation project, and then allow you to use these third-party libraries on the native image. Because unless they're explicitly prepared for that, or build with native images in mind, they are likely to be offenders in that build step. The Graal metadata repository kind of compensates for that with explicit configuration. And part of our AOT step in the Spring build is also preparing your application and everything Spring related for that native image step. Right? So I have a demo brought with me. Let me just quickly go over here. That's the RESTbox example. If you've seen other talks of mine, I'm using that. It's an API that. Let me just run this real quick. Java -jar target RESTbox build snapshot. So I've built the thing in a standard way, and I'm now running it. And it starts in around about 3.6 seconds, 4045. Let's keep that in mind, right? So, and what it does is it provides an API in which you can basically order coffee. So it's actually a showcase for something completely different, like hypermedia APIs, but it's just an application that's running, and it has some kind of UI for us to explore that API. It's just something's running. That's the thing here. So I kill this. Oh wait, we're going to run this again, and I'm going to check the memory footprint of this application. Right? Let's do this. Move it to the background, and then have the memory usage. That's that, and says 370 megabytes of RAM. We can probably, or I played around with this yesterday. We can definitely cut this down to 270 by just running a GC, right? Remember, this is a JVM. It just starts up stuff, and it starts to do things while it's running, and would also perform at some point a GC. And so the actual footprint of this app is at, let's say, 270, 280 roundabout. So let me get this to foreground and kill it again, because the next thing I want to do is I want to run the AOT build. So the jar that you've just seen was not or was a standard Spring Boot Maven build, but at the same time it was built with a dedicated flag saying, please create the AOT metadata and build that into the jar. And I can actually tweak the execution to use that metadata by setting this Spring AOT enabled true flag here, right? Let me run this, and you see it started slightly faster. So it's around about like 10%, 10-15% startup time improvement, because we're now running the AOT processed RESTbox. So it's not performing any kind of class path scanning and reflection instantiations or whatnot, because it's using that static build time generated metadata. But again, as you saw, like 10-15% is probably not that overwhelming. Because like other stuff, like in this case, primarily Hibernate, still needs to do things. So let me bring this to the background again and do JVM map or VM map again to see what the memory footprint looks like. It's 897. So in this case, it's even more. That's a bit surprising, but again, this is I guess subject to running a GC real quick. Also, of course, we actually run a couple more classes, so because they have been generated at build time, and that meaning that we have a bit more memory to use here. Let's get that to foreground. So what I've done as well is I have run the very same build, Maven W-P native. And this is something that you get with Spring Boot out of the box. So the application here, I've developed it for like 5-6 years. So it's gone through all the major or the major and minor versions of Spring Boot, right? And as soon as I had it moved to Boot 3.0, or what you get with the parent POM of Spring Boot 3.0 is this native profile. And it actually uses, you have to have GraalVM installed to create a native binary just by running the same build, just with a different profile and a slightly different default Maven goal. But the idea is that you can get your existing applications running with GraalVM as a native image out of the box, right? So one benefit of upgrading to 3.0 is to explore that path, that you are able to explore that path. And we're going to see what you might get from that. I've already built the thing beforehand because a Graal native image build takes about 5 to 6 minutes, and I didn't want to like watch us a bloody console for all that time. So what we end up with is a native binary in the target folder, and now hold your breath. It's starting in 0.4 seconds. So that's what, like a tenth of the original startup time, right? So in sub-second startup times. And what we also get, let me bring this to background again, and then try the JVM map thing again. Oh, I have to go there anyway. It's what, 74274. You see we're using 60 megabytes of RAM, so significantly like a fifth of the actual memory that our JVM process used. So a lot of this has to do with both the JVM itself having to run and all the JIT compiler that's in there. And early versions of GraalVM had this trade-off where they were incredibly fast to start, but were slightly worse on performance at runtime. But that has changed significantly. So there's no real execution performance difference in GraalVM these days anymore, except the fact that you of course do not have a JIT and it cannot optimize your program behavior based on the execution path it detects at runtime. That's still something that it can't do, but it's not necessarily slow or anything. In fact, it uses significantly less memory, but requires you to like run a build that takes 5 or 6 minutes. So depending on the size of your project, might be even more or a bit less. Yeah, that's it. All right, so less memory smaller memory footprint would be one argument to try to do that. Faster startup times. If you need to like start and stop a lot of applications in production, if you're doing serverless development, then this is kind of interesting. What's also often overlooked is, as I said, the reflection model changes, right? GraalVM native images do not allow arbitrary reflection, which makes them more secure by definition, right? Something like the log4shell bug or security hole would not have happened with GraalVM, or your program would not be affected even if you use that vulnerable log4j version. It would not be by default. It would not be susceptible to those attacks, because you can't just like let arbitrary code be instantiated. So it effectively, quote unquote, disables that feature, not explicitly, but by just the way it works. So you get to a different security model here. That's it for the demo. Let me just kill this thing again, that I do not lose it, and then move on. Are we done? Are we good? We are probably good. Right. So that was Boot 3.0. As I said, significant rework under the covers, which is reflected in the major version change, which is the way that the Spring development and the Spring generations have always worked. So we're not really breaking or shipping any kind of bigger breaking changes with the Spring container or with Spring Boot ourselves necessarily with the new major version. It's more that we raise the baseline for anything that's infrastructure. So whether it's a JVM version, the JakartaEE version, boot 3 upgrades to Hibernate 6, which depending on your extent of Hibernate usage might like cause a bit of effort actually, but that's the things that you can usually expect in the .0 versions of Spring Boot, Spring Framework, what have you, right? So Spring Boot 3.1 was then released in March this year, or May this year. And its primary and its biggest new feature, and that's what I want to just briefly show to you here, is support for using test containers and Docker to run local services. So whenever you run an application, something like this, and this kind of needs a database to actually run. And it actually, it did that. Let me just kill this thing here. This one as well. It requires a database, and by default, it uses an in-memory database, which is kind of nice for development, but it also means that you're quite far away from the actual environment that you see in production. And test containers is a technology that allows you to bootstrap Docker containers containing, let's say, actual Postgres databases, actual Kafka brokers in your applications. And it's been it's widely used. It has been a tool that's been primarily used in integration tests. So you would run your integration tests, the test would start the database, it would shut it down after all the tests are done, these kinds of things. So what we were kind of looking into was whether we can actually use this test containers approach to also support your local development, right? And that's what we ship with 3.1. So you have like a test application here that has a main method as well, which you point to your original Spring Boot application class, include this configuration, and then run the application. So it's kind of the same as the main application class. If you just go here, there's a bit of more stuff on here, but it says RESTbox and it has this main method here. It looks pretty similar. But what it contains is a bean of a Postgres container type that's annotated with service connection. And what that annotation does, and it's something that's been a bit tedious before, was that if you bootstrap an arbitrary Docker container, then you need to tell your application how to connect to that by using a port and username, password, what have you. And this service connection annotation is kind of taken care of. I'm cutting it short here a bit, but it kind of just allows you to not have to think about this. You just say, I want my app to use a Postgres database, right? And we're actually going to do that. We're going to go ahead and say, I'm just running it in Maven. I think it's, oh no, I need MBRT, that's Maven boot test run, MBTR, Maven boot test run, that's the dedicated Maven command for that. And then I use the pdef services profile here. It's just running Maven Spring Boot run, but Maven Spring Boot test run, right? So it picks up the test application class. And you will see that in the log output here, it actually starts the test containers environment. It looks up the Docker environment, and then it kind of starts the Postgres database, and then it says something failed. That's probably because dev services. I need to use the right profile to include the Postgres database driver, of course. You see, now it kind of works. It takes a bit longer to actually run, but it kind of transparently starts the Docker server for you. So if you need a Kafka or any kind of other message broker, any kind of infrastructure, you would just go ahead and add this infrastructure to your configuration here, and then you have something that you can execute locally, right? So a bit of developer convenience. Yeah. All right. There's a lot of other stuff in Boot 3.1, but I want to spend a bit of time on what we have planned for the upcoming release and for the releases after that, right? A big theme, and actually the primary theme of Boot 3.2 is integration, and because underneath Spring Boot 3.2, the Spring Framework 6.1 is going to be released. Boot 3.1 has been on 6.0, but there's a yearly cadence for framework releases. And we are kind of continue to work with a variety of technologies that kind of start to grow, and they probably have been like triggered by this GraalVM effort, right? Because that kind of takes it to an extreme, saying we're building native images, like native binaries, OS specific binaries, and can optimize the hell out of them, right? And the question was, are there any alternative approaches that would get you in the same direction, but not necessarily impose the complexities of GraalVM? As I said, you need reflection metadata. It all looks pretty easy here in the demo, but in real world applications, it's kind of messy because if you just use an arbitrary third-party library that's not really working with GraalVM, and then you're kind of stuck with that, right? So there are problems with that approach. It's just easy with Boot 3.0 to try it out and basically get an impression of how far you can actually get with that. And we actually have customers that like run their applications that way. It's just you're at risk of, if you want to use a new library, then you might face some challenges here. Other approaches have emerged. For example, coordinated restore at checkpoint, short CRAC. I'm not sure that's the best acronym you can give to a tech, but that, and the project Leiden is kind of piggybacking on that. But let me go into those. We're going to support the CRAC the CRAC stuff, or the CRAC technology, with Boot 3.0 to some degree, best effort. I'm going to get to the details in a second. So it's all in the name of runtime efficiency, and the way that the checkpoint restore, as we usually refer to that CRAC thing, because it doesn't have that kind of offensive tone ringing with it, is the idea that you could run a JVM. You could introduce a checkpoint, like a point in time, where you say, okay, this is the state of the application that I want to kind of freeze or snapshot, right? And then you write that snapshot to disk, and then you're able to restore exactly that snapshot at a later point in time. So your deployment process would basically look as follows. You just build the application, you run the tests, and then you're satisfied with the result, and then you deploy it to some environment that's like production, but not necessarily publicly accessible. You run this thing, you issue a couple of requests that get the application into a warm state, quote unquote, and then you serialize that image to disk. And then if you will need to scale application instances, you could resurrect basically those snapshots and get instances running pretty quick, right? Exactly. And the primary challenge that we face, and that we're currently working on, and have come pretty far even, is that we need to a Spring Boot application, if you start it and run it, then it opens up a lot of like connections to a database, accesses files, and what have you. And the checkpoint those need to be managed and basically closed down, and then be restored and reopened at the restore point. Fortunately, Spring has an internal abstraction called a lifecycle that components can actually implement, that would then get triggered on certain events, and then there's some tiny bit of integration that forwards the checkpoint and restore signals to those lifecycle events. So that the alignment of third-party software, again, similar topic or theme as in 3.0, right? We need to make sure that all the third-party software that we integrate with kind of works properly on that, and JDBC drivers, database drivers in general, these kinds of things need to be properly handled, and we're working on this, right? The question is, what what does that approach give you, right? In the spectrum between JVM, pure JVM run on the one side, and the Graal native image one on the other side, you can actually achieve similar startup times with that coordinate restore checkpoint approach, right? You see, there's even sometimes it's even shorter startup times for, I think it's Pet Clinic in this case, yeah, right. So the depending on what like hardware infrastructure you use, there's a bit of a difference in scale, but you see that it's a similar ballpark. If you're only about startup time scaling to 0 in serverless environments, then Crack is an alternative. I'd have to mention it's a technology that's currently supported by selected JDK vendors only. I know Azul is one of the providers, and it's only available for certain operating system environments. So it doesn't run on macOS, for example, yet, especially on ARM processors. So that's why I haven't prepared a demo for that. But I mean, you could probably see the effect here as well. It also it doesn't make a bigger impact on the actual memory consumption of the application, right? And that's probably not necessarily obvious, but easy to understand, right? It's still a JVM. It's been serialized to disk, and it's coming up, and so it's kind of in a similar ballpark. So you're not, if you're looking for the memory implications, then that's not the best, or it's not following the GraalVM numbers here. Another thing that you need to understand is that serialized to disk means serialized to disk. So any kind of in-memory data structures that you hold in there, stuff like passwords or what have you, even if encrypted, are then written to some disk somewhere. So that's kind of something to have in mind. It's an important difference to also the GraalVM approach, because that's not it's just a binary that starts up and runs pretty quick. All right. As I said, there's different efforts in that space, in the performance optimization, runtime performance optimization space. One of them is called Project Leiden. It's a project by the OpenJDK group at Oracle that tries to optimize OpenJDK and the actual JVM for improved resource efficiency, in exploring similar AOT approaches natively in the JVM. And we're actually working, or they've just presented on numbers at the JVM Language Summit, what they were able to achieve. And interestingly, they chose the Spring Pet Clinic and its AOT flavor as a kind of target for studying, basically. And it turns out that you see that the AOT approach, that's the red bar, is that's basically the plain JVM, and our AOT approaches gives you those 10% that we've seen in my demo before, right? When we ran this, and it's becoming slightly more bigger, that gap, if you're running on less, let's say, less capable hardware. There is this pre-main approach that initializes like some parts of the code base like very early, and you see that they can carve off a lot, or like especially on lower cost hardware, carve a lot of initialization time here as well. And that's kind of the work that we're exploring with them. So there's something coming in future JVM generations that will like improve the startup time with standard JVM applications even more, right? And that's so what we're going to ship with Boot 3.2, Spring Framework 6.1, is the support for the coordinate restore checkpoint technologies. There will be documentation updates in the Spring Boot documentation how to use those. And yeah, that's all the other work with Leiden and is kind of forward looking. I would like to summarize. I'm kind of trying to summarize this section, and then we can have a brief interruption before I give you this one more thing. We're looking or summarizing basically the state of affairs for the ecosystem. As I said, boot generation 3 is out now. 3.2 is coming in November. 3.0 has been out for a year. It's based on the sixth generation of Spring Framework. There's a new one coming in underneath boot 3.2 in November as well. There are some other interesting dates here, right? So and a question that's been discussed in the community like pretty prominently recently is that how long we actually support a particular generation of a framework or Spring Boot with updates, with security updates. And there is the usual cadence is a year. So 12 months from now, we kind of expect you to have upgraded to the next minor version. So you see we're on a 6-month cadence for these minor versions, and we kind of allow you to quote unquote to skip one, but you would need to, if you're still on 3.0, then you should be upgraded to 3.1 because you see that the support for 3.0 runs out in November, so next month. Even worse, the open source support for Spring 2.7 runs out in November 23 as well. You've seen that we've given you an extra 6 months on open source support already, because we know that like major version upgrades are kind of hard to execute. After this November, there's only one way to get additional security fixes. So if you're basically working for a company that say, okay, we're not going to get this done in the next 4 weeks, there is an option. We can help you with some commercial support offerings by VMware, VMware Spring Runtime, that will give you, or that extend that support for additional 18 months, basically. In which you get, let's say, should we find a security bug in 3.0 and we know it also exists in 2.7, and let's say it's January 24, then we'll certainly ship a release for 3.0, a bug fix release that's fixing that. But to get access to those by the backported fixes in 2.7, you would have to have this commercial support. That's kind of the idea. There's a couple of other things that you get with VSR. So it's not only 2.7 security fixes, but also access to consulting. There's a Spring Academy involved here. You can like work with us on. You can also like file issues for 3.0, 3.1, 3.2 if you run into something severe. Exactly. So yeah, the other thing that probably should be on top of all the other things here is the required Java versions. So while the 2.7 applications are, they require Java 8, run on Java 17 plus. I'm not sure we're actually pursuing the compatibility of 2.7 on 21, but 3.0 has a 17 baseline, and we're actively building against the most recent and the LTS versions, so-called LTS releases. I'm not supposed to say LTS versions really here, of OpenJDK. So if you want to move to 17 or 21, you're better at on 3.0. Also, for the migration, it's usually advisable to try to migrate your 2.7 apps to a newer JDK already, like before you take the step to 3.0, because it, especially if you're on 8, then you have to accommodate for the module system change in the JDK, and that might take some extra effort. So moving the 2.7 apps to 17 first, and then moving them up to 3.0 is the recommended way. JakartaEE is is in there. 7, 8, and upgrade to 9 means the namespace. And what you get with 3.0 is the Spring Native stuff built in. That's kind of the idea. Do we have any questions so far? If Ulrike, anything?
Yes, we do. We have two questions. One is coming from Divakar. Can we use SBM to migrate from 2.3? Actually, it says 2.3.0 to 3x. I saw the documentation in the GitHub that it supports 2.7.0 to 3.
There is, that's been the screenshot I showed you is not the most recent anymore. There's been recipes in there or put in there that go back until 2.5, but for 2.3, I'm not sure. I don't think we go back that far. Like 2.3 is, oh my gosh, how old is that? 5, 6 years or something. Yeah, so I mean, you could give it a try, or if you find something not working or not being found, that's also like a general recommendation. If you find anything that migrator doesn't help you with and it leaves your code broken or something, then file issues please with a tool. But yeah.
Okay, thank you, Ollie. And then the second question is from Vivek. Will there be a compromise on the incremental application performance options provided by the GIT and C2 compiler as we move to AOT build time?
Oh, that's a bit of a broad question. You've seen that we gain a bit of startup time improvements on the AOT stuff because we skip on a bit of reflection, and parts of those improvements do not actually come from less reflection, but the fact that the AOT mode also like disables, for example, the XML processing or the fundamental infrastructure in that is around for optionally processing XML configuration. In AOT/GraalVM, we assume you're not using that anymore, which means that we can avoid to load those classes in the first place, and that kind of gives you a bit of a performance improvement as well. The effects of the JIT compiler are primarily coming into play when running the application, which means this is time when the AOT processing or the processing of the result of the AOT processing is already over, right? There is significant improvements if you move from, let's say, a Java 8 machine to literally take the very same application, run it with Java 17 or Java 21, then you get quite a significant performance boost by just the virtues of that. I don't necessarily think that our AOT efforts kind of accelerate that in like the effect that you get by the newer JIT compiler and the garbage collection. Yeah, I don't have any kind of numbers on that I could give you to really prove that. So yeah.
Okay, thank you, Ollie. That's no more questions.
That's it for now. Okay, then let me just have this one more thing here. I've previously talked to you about if we talked about like Spring Boot 2.7 and 3.0 and GraalVM infrastructure, JakartaEE, mostly infrastructure, but what we're also exploring, that's not like the all the things that the team is busy with. What we're also exploring is what kind of applications our customers build and what architectural ideas they build into these applications, and how useful or how well Spring supports these efforts, right? So these architectural ideas, and lets me come to a project that we've just announced very recently. Is called Spring Modulith, and it kind of fills that gap in the upper right here, right? So we have this entire Spring Framework ecosystem, and we have a set of technologies that explicitly cater the challenges of distributed systems, of a microservices arrangement, where you need like technologies like a circuit breaker or service discovery, all these kind of things, challenges that arise from you choosing a particular architectural style. And those challenges, due to the fact that you're using microservices, often residing between the applications, right? What we started with the Spring Modulith project is, or what we did here is, we were looking at like what kind of goals are companies usually trying to achieve when they maybe move to microservices, right? What is it? Is it getting to more maintainable applications? Is it being able to test parts of their applications, like logical business parts of the applications in isolation? Or like being able to trace the flow of, let's say, a request through different logical parts, right? There's a request for an order coming in, and that order is processed, and then there's an inventory to be updated, and we can actually follow that request to the other system, the inventory system, see the update. And we were kind of looking at like, okay, what if we were able to solve these problems in a non-distributed environment in the first place, by just allowing you to express that kind of functional structure in a single Spring Boot application. That is not to take a stance on you should build microservices, you should build monoliths, but rather you have a system comprised of, let's say, one system or 5 systems or 100 systems. Even of these individual, each of these individual systems will have some internal structure. If you build fewer independent systems, then there's probably more structure in each of those than the other way around. But there will be some structure, right? And that's why we came up with, or that's basically what ended up in the Spring Modulith project. I don't want to stress this too much here. It basically allows you to express logical architecture in a Spring Boot application. It gives you means to verify that this architecture is being followed, or that if you kind of start to put cycles into your logical parts, we have support for testing parts of the application individually, and also have a stance on how these individual parts baked into your application should interact with each other in an event-based way, VM internal event-based way. And there's a couple of challenges that arise from that, and we're solving those. There is, if we have that information, we can generate documentation and also make the application architecture observable from the outside, which is, allows us to prepare, let's say, our deployment products that we have to work with that information. There's like IDE integration going on that basically shows you all the logical modules inside an application. And generally, just you could just write some tooling that would do useful stuff with that information. It's a pretty young project. We've just released the 1.0 version at Spring One in Las Vegas in August. And there's going to be a 1.1 built on top of Spring Boot 3.2 whenever Spring Boot 3.2 is released in November, like next month. Release candidate coming tomorrow. And we've made it onto the radar of the ThoughtWorks technology, ThoughtWorks folks, basically ThoughtWorks technology radar mentioned us as assess. So I can just encourage you to check things out. I'm going to, if you just Google for Spring Modulith, you find the project page. You find on YouTube a lot of presentations that I've already given on it. I don't want to stress this too much. Zooming out again, I would just wanted to give you an kind of an impression of, oh, we're not only concerned about infrastructure, but also, let's say, aspects of software development that come from an architectural angle and connect basically architecture to the code that you write in a day-to-day fashion, and then eventually also in the way that you deploy your applications. And with that, we still have a bit of time for questions. Don't be shy. I mean, we have a couple of minutes left, so happy to chat, like also outside of the scope of what I've discussed here, but of course also happy to share things on that stuff if there's particular questions.
So currently we don't have any further questions.
I mean, that's fine with me as well. So you all understood what I just presented on. You've like fully grasped it. If in doubt, feel free to get in touch with me on the shown email address, odrotbrom@vmware.com. I'm odrotbrom literally at every place in the internet. Yeah, so thanks for your time and attention. Is there one question coming up?
Yes, there is just one
Vivek.
one further come in.
Just came in. I see it. Does Modulith enforce only application domain boundaries? Can it isolate the application library dependencies? Good question. It is only focused on your application domain boundaries because we see there's been a lot of research going into this, and we've seen a lot of teams try to do some kind of organization around their around the topic of modularity, and most of the tools that try a, let's say, more holistic approach often keep the teams busy with stuff that they don't care about. And we've also seen that the well-defined functional decomposition of your application that matches your domain is the most important thing to keep an application maintainable. Usually the business doesn't care whether your persistence layer only depends on Hibernate and you put some arbitrary rules, like technical rules in there. But being able to develop new features for the business pretty quickly is kind of the primary focus, and there seems to be a sweet spot in that area. I'm not saying we're not going to change this at some point, but by default, we only care about your application's domain, or giving you the tools so that you can care about your application's domain. We don't actually know about your application in the first place.
Okay.
All right.
Thank you, Oliver. Then, yeah, thank you, Oliver. Great presentation, great stuff. And thanks to you all for attending and for your interest. This webinar is also available on demand in case you would like to go back to some things that Oliver has shown. You might also want to maybe recommend it to a colleague or so, and the link should be available fairly soon. Then, yeah, thanks again. Thanks a lot. Goodbye. Have a good day. Ciao, ciao.
Thanks, everyone.